Greetings, everyone. This is the pre-activity for something we will call the free fall activity. Now, what is free fall? Well, free fall is when you're falling under the influence of gravity only. That means that gravity is the only force acting, no applied forces, and especially no air resistance. So the only true place that we have freely falling motion is in a vacuum. But we're going to be able to approximate it in this room through the use of some high tech, so that we don't actually have to suck all the air out of the room and kill everybody. Now, in this activity, we are going to try to determine three things about free fall. First of all, is free fall uniformly accelerated motion? In other words, is it like the motion of a cart rolling down an incline? Secondly, is there a particular uniform acceleration that we can use for free fall, an actual one number perhaps that we can use near the surface of the Earth? And then the last thing is, does the mass affect the acceleration of something in free fall? So we're going to try different mass objects and see if that affects anything. Now, in order to do this, like I said, we're going to kind of have to go high tech. We're going to use something called a picket fence. Okay, it kind of looks like this. It's a clear rectangle with these black bars, and you notice that they look like pickets, right, of a fence. And the special thing about them is that, as it says here in the diagram, from the bottom of one picket to the bottom of the next picket is exactly 5.0 centimeters. And the program that we're going to use knows that because it's made by the same company that makes the picket fence. So basically, this is the setup that we have in the back. It's a little different than this, but it's pretty close. I have a photo gate attached to the table, turned sideways. There's a little soft pad on the floor that you drop the picket fence on, and this is hooked up to the computer. You're going to open up a program called Freefall, and it's going to be basically a big velocity time graph. Why a velocity time graph? Because, of course, we can find the acceleration of an object by taking the slope of a graph of velocity versus time. And in fact, there's going to be a linear fit thing already turned on inside of the program, so it will automatically do that for you and tell you the slope of the velocity time graph. And basically what you're going to do is take this picket fence and drop it through the photo gate. Now what happens here is that you hit start, and the program is waiting until you're ready to drop the picket fence. You don't have to drop it the instant you hit start. You can wait till a little later. But when you drop it, when the first picket gets into the photo gate, it starts the timer. When the second picket falls into the photo gate, now the program says this picket fence has fallen 5 centimeters in this much time. Next picket, now it says 10 centimeters in this much time, then 15 centimeters in this much time, 20 centimeters in this much time, and so on. And so basically, it's like taking two photo gates and making them 5 centimeters, then 10, then 15, then 20, then 25 centimeters apart, and measuring the time between, but doing it all in one quick little trial. The cool thing about that is because these picket fences, as you'll see in class, are very thin, right, and very aerodynamic, and because we're only dropping them about 30 centimeters, we really don't have to worry about air resistance effects. And air resistance doesn't build up to any size that we can really even notice in the experiment. So it's approximating a freely falling motion without actually being inside of a vacuum. So it's kind of a cool high-tech way of doing things. Now, a couple of things about how to work the lab so that you get the best results. First of all, it'll give you a number, but you need to hit stop first to get the final number. Basically what's happening is it gives out a number and it's waiting for more pickets to fall through until you hit the stop button. Once you do that, a new number will pop up in the linear fit box, and you can record that as the slope of your velocity time graph or your acceleration. Please delete each trial before you start the next one. It's just an Alt-. That just keeps everything more organized. You can't run more than one trial at a time, otherwise the linear fit doesn't work. So you have to delete each trial each time. And the next few things here are trying to get you to think about the quality of any particular trial. And that if it's not a good trial, don't write it down. Be discriminating a bit. Think about whether these trials are any good and only use good ones. So your 3 trials that you're going to take for each picket fence should be similar to one another. We have 9 different picket fences in the back of the room. These 9 picket fences differ by mass. There are electronic balances around the edges of the room that you can use to mass these 9 picket fences. And you're going to do 3 trials of each one, and they should be close to one another. If you have an outlier, get rid of it, do another trial. Likewise, you have to make sure that you drop it vertically through the photo gate, as in the picture in the last slide. So if you drop it at an angle, then there won't be 5 centimeters between pickets anymore, and your numbers will be off. Again, if you drop it and you think that it may have been angled or twisted as it fell through, just get rid of the trial. It's not a big deal. It only takes a few seconds, and just redo another one. When in doubt, delete the trial, do it over. Also, it helps if you drop the picket fence close to the photo gate. Rather than dropping it 3 feet above and trying to get it to fall through the photo gate, start it just above the photo gate, and it seems to work best. Don't use any trial where the picket fence hits the photo gate, because that's not free fall. It's more than gravity acting on it. Again, if you're not sure, get rid of the trial, try another one. And we can do many trials in here very quickly. And the last thing is, any trial that's 10 or more meters per second squared, get rid of it. It's not a good trial. And so we're trying to keep them under 10. Again, in order to get good results, you have to do the things above. Drop the picket fence close to the photo gate, drop it vertically, and don't let it hit the photo gate on the way down. The program you're going to open up, by the way, is called Freefall, and it's in the typical place on the shared drive. And again, it's just a big velocity time graph for you to use. Then you're going to fill in all the things on the lab sheet that I've given you, including taking the average of your 3 trials and then the average of all of your accelerations. And then you're going to graph acceleration as a function of mass with LoggerPro in order to see what effect changing the mass had on the acceleration. And please call me over to take a look at that graph for you and explain what you might be looking at, because it can kind of get messy depending on how you put it in. Thank you, and I hope you enjoy this activity.